You're listening to Natural Resources University. In this podcast network, our hosts are university researchers and extension specialists, opening your gateway to the science of natural resource management.
Welcome to Fire University. This is a podcast dedicated to fire ecology and management within the Natural Resource University podcast network. My name is Dr. Marcus Lashley. I'm a wildlife biologist, an assistant professor of disturbance ecology at the University of Florida, and a lifelong hunter that's passionate about wildlife conservation and management. In this podcast, I will interview scientists and professionals, not only on the latest research in fire ecology, but also about their experiences, in hopes that you as the listeners can learn why fire ecology is important and also how you can use it to meet your natural resource management goals. So let's get to the burning questions in Fire University. Hey everybody, welcome back to Fire University. Today, I'm really excited with the folks that I have on here because they're going to be addressing a question that I've gotten fairly frequently and I've also thought about quite a bit, and that's how does fire management affect predator populations? And I know a lot of you out there are interested in this. You've sent us questions in about this, and that's what we're doing here is trying to address some of that concern with how predators are affected by these habitat management practices and whether or not that affects game species. And we're going to talk about that in great detail today. So with me, I have Marcelo Jorge, who is currently a PhD student at the University of Georgia, and also Dr. Mike Cherry, who is now at Texas A&M Kingsville, but has worked quite a bit in much of the Southeast and a couple other places, and has worked quite a bit with fire as it relates to predator communities. So I appreciate you guys coming on today. It's definitely, I think this topic is one that gets people fired up. Got to stick with the fire puns, right? So, Marcelo, one of the things that I was really interested in talking about is a study that I guess you worked on for your master's thesis, right? And Dr. Cherry was leading that project, and it was right here close to home for me in Florida. So can you tell us a little bit about that project and what you were doing?
Yeah, so that project was 45 minutes from your campus, essentially, on a military base. And I guess it just goes directly into that question, like how does fire influence these predators? Because we know, like when we talk about burning, right, we're trying to get the forage available there. We're trying to work on, the cover, what hardwoods are present. We know all that side from the deer or the prey side, right? We're talking about bobwhite quail or anything like that. But I think the bigger question too, follows like what other benefits can we get from fire, right? How can we alter these predators' spatial movements and patterns just by putting fire on the ground? And so that's what we did, set up a whole bunch of cameras, 34 across the base. And at Camp Landing, they essentially like burn everything. Very often, 3 to 5 year rotation, just constantly burning. You see ranges, they got mortars exploding. That sets off more fires and they just let them burn,
Point source ignition.
It was a great place to do that study. And so that's what kind of we were really interested in. For me, I feel like that was the most interesting part, was trying to figure out how does this management really affect the predators? Because we know all the benefits from it for prey species and all that. And I think, at the end of the day, it depends on the predator, where it's at. And what was really interesting, I think, is I got more and more into this idea of, what aspect of fire influences certain behaviors. And because if you look at fire, it's not like silviculture where you can go and you say, okay, we're cutting these trees down at this dBH and we know exactly what's going to happen. You set a fire one year, it turns out one way. You set a fire the next year, well, it's too much humidity or moisture or, several factors come into play. So it's a very variable thing to try and get at. You can talk about the age, the frequency. And so that's what we kind of tried to look at there, is a whole bunch of variables within the use of fire. And go through that.
Well, it's really cool when I was looking at the research that y'all published from that work. you essentially looked at it the same way that I would, and the same way that I think a lot of the listeners would want to look at it, where you grouped predators into nest predators, right? Thinking about turkeys and quail. And then you also grouped predators into fawn predators, right? So thinking about it from a deer perspective. So how did those two groups react to fire?
Yeah, so I think first I'll probably explain one of the key variables was pyrodiversity. And for your listeners, you essentially think of it as patch mosaic burning. That is essentially a type of fire diversity, right?
Sure.
Martin and Sapsis published and defined it way back in 1992, but it's gotten more popular now. There's a lot of work in Australia about it, where if you look at all the more recent literature, everyone's defining it in different ways, because you can do diversity based off of age or intensity, seasonality, right? There's a whole bunch of ways, different scales, if you're talking about within a plot or across. So we looked at it just basically at the age of fire across the base and say, okay, when was this plot burned? When was this one? And so we define that as our pyrodiversity index. And interestingly, bobcats and coyotes, right, these two big fawn predators, they were less abundant, it's relative abundance, but they were less abundant in these areas where there was more pyrodiversity, meaning that they had varied years of burns within this buffer zone that we've created, which is 1,500 meters.
Okay, so basically you looked at plots of land of a couple thousand yards or 1,500 meters, is that what you said? Yeah,
around the cameras.
And you developed an index for how diverse is the fire regime within that. And the more diverse the fire was, so in other words, the more time since fire, having different age classes since burn, right? That's what you're saying. They were less abundant the more diverse it was?
Correct, yep. Yeah.
That's really interesting.
Kind of gets away from the idea of like doing these big, massive burns, and covering the whole area, where you could say, let's cover as much acreage as you can in 1 year, but let's separate it into little chunks, right?
Yeah. So you always want some stuff being burned every year.
That's right.
You may have the same acreage burned, but you're just spreading it out over years. So yeah, that's really interesting. It fits in with a lot of the work that I've done over the years and a lot of other scientists, and kind of talks to that same thing, that pyrodiversity could be really important. And in this case, maybe for the prey, that pyrodiversity could be important by reducing predators. So that's kind of interesting. What about the nest predators?
Yeah, for them, we had mostly, I think raccoon was the biggest aspect, where if we had a recent burn, which we defined as less than a year, they were less abundant in these recently burned areas compared to the areas that hadn't been burned as recent.
Yeah.
And they were avoiding pine stands, and they weren't significant, but it was trending towards obviously going closer to hardwood stands.
Okay.
So the things we kind of know about raccoons, but also with that fire aspect of, if there's a recent burn, they're lower in relative abundance in those areas.
Oh, wow. So having your upland pines being burned in the same year reduce the abundance of raccoons.
That's right.
That's really cool as well. So there are a couple of things, and I wanted to switch a little bit, Mike, because I know that you have experience with a bunch of other study areas with different assemblages of predators and different systems. So things might change across those. But one thing that I think would be a good point for us to discuss, and something that we probably all come in contact, I know I certainly do when I'm talking to landowners or hunters, we kind of have this perception that habitat is driving the abundance of our prey species, and we have a good handle on that. But I don't know, people often assume that predators, or I kind of get the feeling, and I certainly think I probably even do this to some degree, sort of think of predators as being independent of habitat, and that being solely driven, their abundance being driven strictly based on the abundance of prey. Do you think that is an accurate way to look at it? Or, are they operating independent of habitat, or are we actually influencing habitat quality, and in other words, plant community structure, in ways that benefit or is negative towards their population that is independent of the effects on prey?
Yeah, that's a good question, Marcus. I think that carnivores in general are absolutely tied to vegetation structure. I mean, prey abundance is a key factor driving the distribution of predators, but so is prey availability. And I think that's really where this vegetation structure part comes in. So if you have a predator that's really tied to concealment cover, and it really needs concealment cover to stalk and kill its prey.
Like a bobcat,
for example. If you have that kind of system, there could be a lot of prey in a given patch that a bobcat can't access because it doesn't have the stalking cover. And so when you start thinking about how fire influences concealment cover, which can give an advantage to the predator or the prey, depending on the predator-prey context, then the vegetation structure is critically important to the distribution of predators and any influence they're going to have on the prey communities that we're often managing. So I think fire has a really prominent role in driving the distribution of resources, so prey animals for predators, but also their effectiveness across the landscape.
Mm-hmm.
And so I think I started thinking a lot about that in terms of prey availability and that predator-prey context when I started seeing different responses in deer to fire relative to which predators they're most concerned with.
Yeah.
And so you and I, Marcus, we both cut our teeth studying deer where they're primarily focused on staying away from coyotes during the fawning season.
Mm-hmm.
And in that system, the thicker the cover, the better for the deer, because coyotes are predators of the open. They like to course and find the prey. In other systems where you have, Florida panthers, for example, another stalking ambush predator, I found the exact opposite, where deer felt really comfortable out in those recently burned areas because they could see there was no predator, no panther stalking up on them. And so how that structure, that vegetation structure drives predator-prey dynamics has been something that I've thought a lot about. And I think that a lot of prey species are pretty flexible, like deer,
Mm-hmm.
and it depends a lot on both the predator and the prey in terms of their natural history attributes and how vegetation structure affects their role in the system.
Yeah, that's really, really a good way to think about it. And bringing up some of your work in South Florida with the panthers, it not only did you see the stark difference, I guess, in deer behavior in terms of where they feel safe. The way I understand it from you and from reading a lot of your work, they feel really safe out in the wide open, sort of like a grazing animal out west or something, right? Mm-hmm. And that's kind of foreign to me. But the other thing that I found particularly interesting, and I know you saw this and some of the folks you worked with have studied it, it was really interesting that the panthers are really efficient hunters during crepuscular hours or near sunrise and sunset, and also at night. And deer down in South Florida, when are they most active in response to that?
Yeah, it's really interesting. It's a really interesting system down there because the deer are strongly diurnal.
Yeah.
As are the raccoons, who are the number 2 most important prey item for the panthers now, are strongly diurnal. Yeah. Quintessential nocturnal predator.
Right.
And
what
down
is,
there.
So just to make sure everybody's with us, what's diurnal?
Diurnal, sorry about that. Yes, a diurnal would be an activity pattern that's characterized by the majority of the activity happening during daylight hours. So the opposite of nocturnal.
So, and I seem to remember looking at some of the work that you've published and looking at those activity patterns, and they're almost hump-shaped around. Mm-hmm. I don't know if they're necessarily centered on noon, but there's this hump where they're much more active during the middle of the day, it seems like. And to me, especially, it's weird to think of deer that way, but you brought up raccoons, and that had slipped in my mind. That's pretty wild.
Yeah, and I think that kind of goes to talking about, or goes to show the role predators can have in shaping prey behavior as well. And I think that's another key component of how fire influences that predator-prey relationship. And so it's remarkable how much a deer, for example's behavior can change relative to time since fire, and how much more effective foragers they can be with more concealment cover and things like that. And so it has a really important has a really important role in predator-prey dynamics, not just in defining when and where predators are effective at killing their prey, but also in defining how prey respond to predators in a given time.
Yeah, if we haven't thought about this as being complex. We certainly are getting there quickly, right? So now my mind is spinning about, okay, we've got fire affecting plant communities and that structure affecting prey species, which affects predators, and we often think of it very linearly like that. But the other thing is that the vegetation structure might affect the predator's behavior, or where it's more abundant, or how efficient it is, which then feeds back on how the prey species view, I guess, the structure in terms of what it's good for or not. And then you, of course, know some of my work where I've even been looking at feedbacks back on the vegetation from the way that prey, is particularly deer, use it. But to add to that, I know you've been really interested in some of the indirect effects of predators and systems, and I thought it might be interesting to add even a little more complexity to that, to think about it, since we're thinking about raccoons for a minute. How do, like panthers, you said that one of their prey items are raccoons. How do they affect the abundance of raccoons? Are they pretty good at regulating their populations?
I don't know that we had the data to say regulation. I don't know we've had the funding, the research to really look at what's driving these raccoon population dynamics in the presence of the panther, but they certainly eat a lot of raccoons.
Yeah.
And we know that. And we also know that they influence the behavior of raccoons in some interesting ways. So like the activity patterns that we were mentioning before. And so I think that panthers have the opportunity to greatly influence raccoon populations. But so do a lot of other things in South Florida, like pythons and other types of things. But raccoons, I think, are really one of the ones that made me, I gave that deer example right out of the gate and how I started thinking about the role of fire and predator-prey dynamics. But raccoons are what sort of drug me into thinking about this a lot. And it was when I was working at the Jones Center. They were undertaking about a decade of a lot of intensive hardwood cleanup in their upland pine stands. And so they were removing the mesic oaks from these upland pine stands. So where water oak and other things had encroached into these uplands, they were going around and they're taking a lot of these out, which were really, raccoons eat acorns, but they also use those for den trees and a really important refugia. So if they are getting chased by a coonhound or a coyote or whatever, they can go up a tree and get away. So those are really important refugia for them, daytime refugia, but also just getting away from predators. And so if you're starting to do these silvicultural treatments that limit the distribution of hardwoods in a pine stand like fire does, how does that ultimately impact the species, this raccoon that's really tied to these hardwoods? And then I started thinking, and some of your work really got me thinking about this, Marcus, too. And a lot of the predators in the Southeast that we're so focused on eating quail and turkey and deer are omnivores. And they spend a lot of time making a living in the summertime eating soft mast. And I'm by no means advocating to burn to the point where you don't have any soft mast for your wildlife, but an upland pine stand that has no hardwood trees and all of your rubus is 1 year old and doesn't produce fruit is not as attractive to a raccoon as an upland pine stand with, a couple big oak trees per acre and a lot of fruit producing soft mast that oftentimes takes a couple years to get to the point of making fruit. And so we started thinking about how fire is ultimately influencing the quality of a longleaf stand for raccoons. And does that ultimately then feed back to affect their use of those upland stands or their abundance in those upland stands? And how does that affect the nest success for anything from a bobwhite quail, turkey, gopher tortoise, anything that raccoons can be important predators of? And so that's really where this thought about how fire is influencing predators and predator-prey interactions really came, was from thinking about raccoons. And a lot of it is that fact that they're not just predators, they're also competitors with a lot of these game species. They're all just looking for a berry in the woods, and sometimes they find a nest instead.
Yeah, it's really easy to catch berries.
Yeah.
Yeah.
But you can't burn so much that you don't have them. That's the key.
Yeah. That is an interesting way to think about it. And that was something that I had worked on the berry side of things. I've looked at how fire affects fruit production in a few systems now. But yeah, that's really interesting way to think about it. And again, kind of speaking to a lot of the conversation we've had, that there could be benefits to having fire on the ground at all times, and a really diverse way you might gain and lose from different things in that scenario. And yeah, it's interesting to think about raccoons. And I know a lot of our audience are probably thinking about, well, raccoons eat turkeys, at least when they're nesting, right? They eat the eggs. So one of the primary nest predators. So a lot of people might want them to be less abundant. I know that they do, because they ask me how to make them less abundant a lot. So, and then I'm an avid hunter, and I know that I want my deer population to be diurnal. It seems like the big predator down in South Florida is doing you a solid on that end, right? So yeah, it's really interesting, and that's why I wanted you guys on here to talk about all these different intricacies, right? This is a system that's really complex, and depending on where you are and why you're burning and how you're doing that, you could really affect things in different ways. So what about, I know you've done some work in upland hardwood systems as well. I think it might be interesting to bring some of that in, since I know a lot of our listeners are also thinking about burning in those systems. So what kind of work have you done, maybe up in the Southern Appalachians work?
Sure. Yeah. So we were conducting a pretty large scale predator prey study in Virginia with Marcelo Kelly and Mark Ford, and working with in tandem with a state agency there in Virginia to try to better understand how predators might be impacting a deer population in a system that has a lot of things going against it. So it's already shallow, rocky, steep soil, and it's got senescing hardwood stands that are probably not at their peak acorn production anymore, mesification of those systems that are shifting a lot of the oak and hickory stands away from that and into poplars and maples and things that aren't quite as good for hard mass seeking wildlife like deer and turkey. And so we did a study where we looked at both the predator side and the prey side. And so we deployed GPS collars on deer, bears, coyotes, and bobcats all in the same area. And what was so exciting about the area we were working is that it's historically a fire-dependent system. People don't realize this, but that front ridge and valley is incredibly dry mountain range that is built to burn. And it's one of these systems that was basically pulled out of that historical disturbance regime, and fire was stopped. And so culturally and ecologically, the fire culture was broken. And ultimately what they're doing now is they're realizing the benefits of fire and its capabilities of reversing some of those mesification trends and its capabilities of putting soft mass in the landscape. So we just talked about how fire takes away soft mass if you put it in there frequently enough, but it also develops soft mass if you go into a closed canopy hardwood stand and pop a bunch of patches in the canopy. All of a sudden you got vaccinium and rubus and other things coming through that they haven't had in a long time. And so we worked in that system. It was really cool because it was almost like a reintroduction of fire was going on in that system over the last 10 years or so. And the Nature Conservancy was a major player in that. And so we had a system that had some pretty severe fires, intentionally severe fires put on the ground that popped a lot of canopy holes and gaps. And what we found was everything really liked these canopy gaps. And so the deer, of course, are attracted to it because they can actually reach the plants that are getting sunlight. The carnivores are attracted to it because there's cover and fruit and these other things. But what was really interesting, one of the things that we contrasted there was the difference between prescribed fire or wildfire, just fire in general, and timber harvest, which also creates these gaps. And so the timber harvests are all around 40 acres or smaller. They're trying to make these nice small patch openings, and the fires could be over several thousand acres. There's a lot of severity or heterogeneity in severity because of the topography there. So you get unburned patches, and the aspect where you get these cool sides of the mountains that don't burn. So within that 1,000 acres or 5,000 acres, there may be a lot of unburned patches. but the scale is so much bigger. And so what we started to see in that study, everything liked to go to the openings, whether it was a timber opening or a fire created opening. But the problem was the scale. And so these tiny burns, these really small, even logging decks or 40-acre cuts, they're so small that if a deer is attracted to that to get that forage and hide their fawn in that patch, it's really quick for a bear to seek that or search that whole 40 acres. But if you drop a fawn in 1,000 acres of waist-high vegetation that's regenerating, it's a lot more efficient for the fawns to hide. And so they're both good openings. They both create food, but the scale is so different that the deer don't stand a chance when they hide in these little timber cuts or logging decks, but they do a lot better when they hide in this big fire opening. And so that was one of the main findings that we found out of that study. The second big thing is the predators, particularly bobcats, really were attracted to these fire-created forest openings. And so we published a paper a year or so ago in Forest Ecology Management where we showed that relationship where the bobcats were selecting across all seasons to be as close as possible within the forest near those burns. And so it really showed the response to fire, not only of the game species that the agencies are trying to manage for hunters, but also for carnivores that are responding to the small mammals. And it's sort of an indication that there are multiple trophic levels that are responding positively to these openings and this reintroduction of fire into a previously fire-dependent system.
Yeah, that's really interesting. I've done a fair amount of work similar to that in different systems and have seen this widespread magnet effect, so to speak, that you're talking about. You also bring up something that I think we should talk about more with the scale issue, and I think that's really important. I saw something very similar in some of my studies in longleaf system, I think, and I was just curious what you thought about this. The landscape context that you were in is so important to understand the role of scale in that case, right? So when you had these small patches, 40 acres or less, or whatever scale you were talking about, basically all of everything around it was closed canopy hardwood. Is that?
Yep.
So you basically, now you've taken a system that essentially doesn't have any fawning cover, right? Or very little of it that we would call high quality fawning cover. And then you've created a forest patch. And some people might think of that as a big forest patch, but in that landscape, that's pretty small, 40 acres even. And you've concentrated all of the good fawning cover in that one location. And of course, the doe is programmed to seek out that location. And it also is really easy to get a search image for where you need to look if you're a bear or a coyote or something, right? So it's kind of, in that context, created a problem for the prey species, at least, and a real advantage for the predator because there isn't anywhere else. You have to select that high quality good stuff, or you're programmed to do that. And that's pretty similar to the work that I did in North Carolina in longleaf, where the scale of burning, it was actually the opposite relationship that was causing the trap. But I thought it was really interesting to compare how similar the problem was with how different the problem creation process was. So they were burning at massive scales in that system, and it was very complete burning because it was longleaf and a wiregrass plant community that often burns really complete. Super poor soil. It's 15-foot deep sand, essentially. And essentially, when you burn at 1,000 acres at a time, or a couple hundred acres or whatever, you have the uplands are essentially for several months devoid of high quality cover, and the little drainages running through that system don't burn because of moisture, and they're very narrow strips of vegetation that appear to a doe to be really high quality fawning, but they're also really easy to hunt for a coyote. And that's exactly what we saw when we modeled out the effects on fawn survival, is that essentially if a doe put her fawn in those strips of vegetation, they were much more likely to get predated, even though it was better cover. So it was the opposite relationship we would have expected, but it was driven completely by landscape context. And it sounds like that's a similar thing, even though the scale in the two systems is kind of reverse of one another. It's still the same issue where you've concentrated all the good stuff from the prey's perspective and the predator's perspective.
Yeah, and I think in your system there, Marcus, it's the worst possible case for deer, because you create an opening that a coyote's really comfortable coursing through and running, and then they got cover that they can basically win the whole strip at one time. So they run the side of it and they find everything that's hiding inside of it. And it's basically the worst case scenario.
Yeah. That's really interesting and important, I think, to think about because of the diversity aspect that Marcelo was talking about, that we're all of these issues, I guess, as a manager, the way that you get around it is to start thinking about diversity.
Yeah, and honestly, when Marcelo came up with doing this pyrodiversity metric and how strongly it was predicting the distribution of particularly bobcats and coyotes, I was really excited and surprised at the strength of that signal. And as we sat back and thought about it more, and really what I think drove Marcelo to originally create some of those metrics is, there's abundant data out there that shows fragmentation will negatively impact bobcats and coyotes. But most people are thinking about fragmentation as the dominant canopy species change, or you go from a forest to an opening to a development, these dramatic changes in patch types. And we weren't really thinking about it in terms of those dramatic changes in patch types, but within a pine system, there is pretty dramatic differences between a 1-year rough and a 3-year rough. And so it's basically the canopy's all the same, but in that system, it was almost operating like fragmentation. So these patch mosaic burns that people have been advocating for decades in longleaf systems, they're basically creating a fragmentation type of process that was not suitable for these predators. The coyotes and bobcats needed a little bigger patch to be effective hunters. And so I think that was what was really interesting to me, is when Marcelo came up with that work, it was basically linking a lot of information we already knew about the natural history of predators, bobcats and coyotes in particular, but then creating a new way of really thinking about fragmentation in a fire context. So it's fragmentation of fire history, not of patch type necessarily, which was the novelty of his creation in my mind.
Great job, Marcelo.
I thought I came up with it myself, and then I actually did some more research, realized, no, I did not come up with it myself.
You read it somewhere.
Regardless, I knew. Yeah, like at least it reaffirms that like I was thinking in the right direction, where it's like, okay, other people have thought this more thoroughly. And a lot of the work, like in Australia, I think they take a lot from the Aborigines as well. I think it makes sense that it works there, and then you see some of that pyrodiversity work in Africa as well, where I think a lot of this is all pretty common. These are all really pyrrhic systems that burn frequently. Yeah,
I think that's another thing that we probably don't talk about enough, that I'm glad that you brought up, is we live, outside of the oceans, right, or where there is standing water, we pretty much live on a flammable planet. And fire has played a pretty important process in a lion's share of the uplands, at least on the planet. And we're using fire for a variety of reasons around the world, but it's pretty well been an important process, and it makes a lot of sense what y'all are talking about with this diversity. I mean, when lightning was generating a lot of fire, or whether it was native peoples wherever you're at, there's been a lot of fire on the ground, and it's been extremely diverse in those contexts. I like that also about what you did with that study, and thinking about how complex these systems are, and really the way for us to accomplish our objectives, regardless of what that is. The most effective way usually is to try to think about how complex it is and diversifying what you're doing to, have a little bit of everything, right? It's kind of the idea is to create that diversity, and sounds like you guys were right on point with even operationalizing that by mixing it up with your fire regime. You can even do that.
Yeah, and even, one of the biggest things with that pyrodiversity, I think it all started with, how do we create biodiversity? So how do we get, more species richness, different species on the ground? And there's that hypothesis that's just been holding up, saying, yeah, with more pyrodiversity, you're getting it. Because then it makes sense, right? Because you're fulfilling the habitat requirements of one species within one patch, another one with another, and they kind of have everything they need. Some species, they forage in recently burned areas, but they nest or they, rest during the day in these more concealed areas. Like, it makes sense that you have both these options and kind of a little bit of everything to choose from.
Yeah, having them close access, and you're giving more prey opportunities and probably higher hunting efficiency for some of the predators in many of those contexts. And at the same time, you're also giving prey the resources they need to avoid being eaten, which I guess is number one, right?
Oh, yeah.
Don't get eaten. So it's really cool way to think about it. And there was I don't remember if it was a journal article title or a quote in one of them, but I remember somewhere that it just basically said pyrodiversity begets biodiversity.
Yep, that's the one I was thinking of. Yeah.
Yeah, it sticks in my head all the time. And it really, that has been extremely influential in my work through the years, looking at things a little different in different systems. But that same idea seems to always come back, is that pyrodiversity.
Like the rest of my master's thesis chapters were essentially that on different species. So we looked at the bird community, and the same thing came through, saying, and hopefully we're going to get it published relatively soon, but more pyrodiversity, you had a greater, number of different species of birds hanging out in these areas as well. So it follows the same path. And then all the we did work with Dr. Ford as well, and we did some pretty unique work where we'd go in and we'd burn a bat while it's roosting in a tree and see how it was responding, right? Because that was a big worry some people had about, are you going to start negatively influencing the bats once they've migrated down and all that? And, so we looked at that and saying that, no, there's that fire is creating this kind of, that diversity that bats need, even whether they want to go into, near water where there's plenty of cover and there's tons of insects, or go out into these open areas, because they'll go up in these pine trees and they'll thermoregulate, get the sun, they'll go to the tallest, biggest pine they can find. And how do you grow that? And then even in like the really music areas within, these swamps and these marshes, they were selecting for longleaf pine trees and other pine tree species that need fire. So like at some point or another, you're going to have to go and burn in those areas. So, for a wide range of species, it's beneficial for.
I feel like I have to step in here, Marcus, and provide a bit of context to explain the sentence that we burned a bat in
I was like, I was literally thinking, okay, you had a lighter on the bat, and how did it respond? It didn't like it.
Wasn't a big fan.
The catalyst for this
study, tried to get away.
This was funded by a DoD legacy grant, and honestly, DoD's operations on the East Coast now are being dominated by bat management, largely because of white nose syndrome, and especially in the Northeast. It's affecting operations. All the need for compliance associated with that. It's a nightmare for the DoD and trying to stay in compliance for it. And so, what really motivated us to do that study that Marcelo was describing was a suite of migratory bats that aren't affected by white nose, because white nose is a cave-dwelling fungus that only affects the hibernating bats. But the migrating bats that head south for the winter to come eat bugs in Florida are also declining, largely, or at least in part, it's thought to be because of wind energy development. And so that's a major stressor on some of these migratory populations, because, the pass in the mountains where the bats always fly through is also the good place to put wind turbines.
Sure.
And so there was beginning to be some concern about, well, what do we do if some of these migratory species also get listed? Because some of them are incredibly widely distributed and can affect a lot of installations. And so one in particular bat that was a potential problem is the eastern red bat. And the reason it's a problem is it's migratory. It has the potential to decline because of increased wind energy development. And it's a problem because it actually ground roosts during the day. So it'll get into the leaf litter and just roost on the ground. And anecdotally, bat researchers have noticed that when you're doing telemetry on bats in the daytime, if it's really cold outside, so in Florida, if you have a 50-degree day or 40-degree day in the morning and you go out, that bat takes a long time to arouse. It's almost in a state of torpor overnight, or during the day, I should say. And when you walk up on it, it takes quite a while for it to wake up enough to flush. You walk in on it and it's 75 degrees and they flush when you're still at 50 yards away. And so they're slower to get up. Now, when you start thinking about how much we've shifted our fire management from growing season burns to these dormant season burns that are beneficial for some civicultural reasons and for game management reasons and honestly just fire management reasons, there's a motivation to do it in the dormant season, but there could become an issue where if the red bat or any of these migratory bats were to become listed, how would that negatively impact DoD's opportunities to burn? Is it going to reduce even fewer burn days that are available to a base on a given year? And so what we wanted to do is try to develop some best management practices or identify, is this something that we should even be concerned with? Are these fires in the dormant season going to negatively impact these bats that are ground roosting? And so we misnetted some bats, figured out which stand they were in. We collaborated with the fire team, which miraculously was able to pull together a burn plan for a given unit wherever the bat happened to be that day in time to come out with a dozer, rip a line, and set the block on fire. And what we found is that the bats already know how to do it. They go into these burn units and they're finding these tiny little unburned fire shadows. And they're getting into those stands and they're getting high in the canopy. And even when you smoke them out and burn around them, they're fine. And very rarely do they even fly away or need to. Now, ground roosting is a nut that we have yet to crack because of some things that we're still chasing. We didn't find any that were actually ground roosting during our study. But it's an important thing because it has the potential to affect forest management and our capabilities of burning on these bases. And so trying to get out in front of it was the reason why we were burning beneath these bats, or as Marcelo says, burning the bats.
Hey, it's a catchy slogan, gets people interested. And the other thing I think too that was interesting was they've had studies further up north where they saw a lot more bats roosting in the leaf litter. Ours didn't in North Florida, but there's been anecdotal, accounts of when they burn, they'll see a bat or two flush out. And I think the key there is it's dependent on temperature, because there's been some studies where you see they're roosting lower and lower, closer to the ground, the colder it gets. So I think if you find that nice, temperature window, say this is when they're down there, you could, say, yeah, sure, we won't burn this day, but when it's above X temperature, you're good to go and call it, So I think that's probably what's driving it. Not that we know for sure, but likely some more northern states are going to be worried about it versus, South Florida is not going to be as worried about it.
Yeah, that's a good point. And I'm starting to see now why you were burning the bats. You really were just trying to warm them up so they'd flush, right?
That's right.
How fast can they warm up? That's really cool stuff. And I guess we could think about, staying on the theme of predators. Bats are predators too, right? Of insects, at least. And I don't know what the diet is of that particular bat, but I assume that at least a lot of bats eat mosquitoes, and I don't like those. So, yeah, really, really interesting stuff, guys. I think that was really cool and sort of gave us some great take-home points that diversity is really important and context matters a lot. And, when we're failing to have the appropriate diversity, we might miss some objectives there. Before we wrap up things, I was curious, is there anything else that you guys want to cover?
The one thing I think is interesting is the idea of time too, right? Because we have all these factors that are playing into our burns, whether it's intensity or seasonality. But I think the response too, even by predators or prey, whatever, it's a matter of, is it the next day after a burn? No, probably not much is going to be wanting to go there. There's not much to do. But then 2 weeks later, you get that growth, right? So even within just looking at time within one burn, you could see these great variations of what the effects might be, whether they're being attracted to or avoiding these kinds of areas.
Yeah, and that's changing through time.
Oh, yeah. And especially at the short scale, but then also, obviously, once you go 20 years, it's a lot more easier trend to follow. But even within that short scale, you can see these undulations, I'd imagine.
Yeah, several of the students in my lab have been working on exactly that, is thinking about the temporal scale and how it's affecting use. And you weren't thinking about turkeys when you said the day after. We pretty commonly see them in there the day after, and even quail. We've been seeing quail pitch into the unit before it's done burning. So that's kind of interesting. But definitely a really good point. And again, showing us how important it is to have fire, some of your fire occurring each year rather than all of it in one year. It's another good reason to think about that. So go ahead.
Oh, just like picking just even like the right month so you can catch the green up when, fawning's happening, so they have that concealment cover.
Sure.
Yeah, I think that's a really important point to think about too. And I know, Marcus, you're constantly getting questions about burning during the nesting season or burning during the fawning season. And there's certainly trade-offs associated with that. Like if you can put a fire on the ground that's going to feed deer a lot of really good nutritious forage, that's going to be a benefit. But also it's important to maintain that concealment cover. And they need both. They need high quality forage and they need concealment cover. And so it's a time in their life when they have the highest risk of mortality to their offspring that are totally tied to concealment cover. I mean, they have cryptic coloration. They have behavioral attributes like bedding between foraging bouts that really make them efficient for hiding. But the does also have the highest energetic demands of their lifetime that first month following parturition. And so you need to have both available to them or they're just going to pick the food every time. So what that really gets back to is this timing is important. But if you're going to burn in the summer, that's fine. But think about scale, because Lowe's home range might be 300 acres in North Florida. And so how do you get all of those resources, the food, the cover, in a proximity that allows a single doe to have access to all the things they need?
Yeah.
So it comes back to that scale of fire, both from a time standpoint, but as well as spatially, trying to make sure you have these small patches that can give you all those different resources at the scale at which an individual deer can take advantage of.
You're trying to get all the habitat components close enough so that they can readily use all of them for whatever their needs are. And just to add to that, with some of the nutritional benefits of changing the timing, like we were talking about for lactation in deer, not only is it important to have that concealment cover directly adjacent and it arranged in the landscape at a spatial scale that they're both usable, but the nutritional value of that might also be particularly important in that context, right? So a lot of people might immediately, I'm just not going to burn then, so they'll all be concealment cover. But some of my work and some other work that's coming out has shown that resource pulse associated with that timing could be pretty important as well, especially in really low productivity places. So yeah, really important concepts to grasp and think about.
Yep. Timing's everything, Marcus. Just a key thing managers can keep in mind is don't burn before the drought.
Yes.
Good stuff.
You don't have that problem in South Florida.
Here in South Texas, you can do a nice burn and it can look exactly the same 2 years later because it hasn't rained on it yet. So
yeah, you
can plan that rain associated with your fire management. You'll be in high cotton.
There you go. Yeah. Well, you let me know when you figure that one out. Yeah. Well, all right, guys, I guess we can start closing things out here. I always like to let people know where they can find you if they're looking for you. So where should people look for each of you if they want to ask additional questions or just follow what you're doing?
I'm on Instagram and Twitter as @Wild Haidar, Haidar. So Wild Haidar for both of those. And then also if you just go to the University of Georgia Deer Lab, I have my little email there that you guys can contact me anytime. I'm usually posting now about Arkansas and CWD, but always a big fan to talk about fire.
Cool.
Yeah, and so you can find me. I'm at the Caesar Kleberg Wildlife Research Institute, and so we have a website here that you can find the deer program page and has all my contact information. And we're also active at CKWRI on Twitter, and so you can find those posts there on Instagram and Twitter.
Cool. Thanks again, guys. It's been a great conversation. Really good to see you. And let's not make it such a long time next time. I want to see you again soon.
Sounds good, man.
Yep. Appreciate
It's great being with you, Marcus.
Fire University is part of the Natural Resource University podcast network, funded by the Renewable Resources Extension Act. If you like what you heard today in this episode, please follow us on all the social media platforms at UF Deer Lab.